Let's record that. Okay, superb, superb. Share screen. Okay, so last week on Thursday, we started simultaneous equations. Okay. Okay, we started simultaneous equations, and I said to you that we're going to carry them out in that elimination method. Okay, so that's very important for the simple fact that you either might have seen a different method in school and you might have that in your back of your head, or if you've got a tutor, they need to be aware that we're doing the elimination method, or if you're looking at another resource, it might go through it in a slightly different way. So just be aware of that with simultaneous equations. There is two methods that are taught. Okay, we're going to stick to the elimination method and we'll just keep it at that. Okay, neither method's better, neither's worse, neither's easier. Okay, elimination method just works. Okay, that's good. Okay, so let's do a couple of simple examples. Okay, we'll walk through them and we'll get back up to speed with it. Okay, so essentially simultaneous equations, we've got two equations. Okay, we've got two equations that we're going to use to find both unknowns. Okay, and those unknowns, okay, can be an intersection of a graph, or those unknowns could be something else. Okay, and that will become apparent when we look later on at some story questions. Okay, and I sort of mentioned story questions last week when we were doing inequations. Okay, so story questions, when we go through and it gives you in effect a story and you need to pull data from it. Okay, so you can use simultaneous equations for that. So we're starting with two equations like so. Okay, we'll be familiar with that sort of setup of equation. Okay, remember, you use this, or you can use this to look at where the intersection of two straight lines is. Okay, so that's just a rearranged equation that's effectively y equals mx plus c. Okay, we've just moved the x over. Okay, first step, how we want to do it, you won't always get it in that format, you won't always get it in that setup, so you might have to rearrange a wee bit, so you might have to bring the x over or the y over or move the number. Okay, so you might not get it in such a simple format. You're starting with two equations, equation 1 and equation 2. Okay, the first step that we want to do, okay, let me just check what we wrote down. Make sure the letter terms, okay, are on the left hand side, which we've done. So both the x's are in a column, both the y's are in a column, and the numbers are in a column after the equal sign. So the letters are on the left hand side, all the numbers, the whole numbers, are on the right hand side with the equals in the middle. Okay, the x's, just write them above each other, the y's, write them above each other. Just be conscious of what's happening with those signs in between. Okay, so we want all in a nice row, because we're going to try and eliminate one of those letters. Okay, going to eliminate one of those letters. How we're going to do that is we're going to make sure the number in front of the second term, okay, so in this case the y terms, we're going to make sure the number in front of those terms is the same. Now, in this example, it's a really basic example. There should be a 1 there effectively and a 1 there. Okay, so the numbers don't change. We'll look at when numbers do change, okay? So the numbers are the same. So the numbers in front of those second terms are the same, okay? So I write that a wee bit better. We wrote a 1 there and a 1 there. I cannot draw ones tonight, my God. Okay, so remember in algebra, we don't write that one, but if there's a y there or a letter there, it means there's a 1 in front of it. Okay, so the second thing, the number in front of that second term has to be the same. Okay, and we'll look at how we manipulate that to allow that to happen. Now, in this case, they are the same. Okay, so the next step is we want to do an addition or a subtraction. Okay, effectively, we're going to add both of the x terms together, both of the y terms together, and both of the whole numbers together. Okay, so staying in that column, we're just going to add x plus x. That's going to be 2x. Okay. In that column there, we've got plus 1y, negative 1y. Okay, if we added them together, we get 0. Oops. And underneath that, okay, we're going to have negative 3 plus 7. That's going to give us 4. Okay, so what we've done there is we've eliminated that letter y. Okay, so we've added the first equation with the second equation. So we've added the x's together, the y's together, and the whole numbers together. Okay, that's left us 2x equals 4, which allows us to find out the unknown, which is x, by moving that 2 across. That leaves us with x equals 2. Okay. Then the next stage is we take that answer and we substitute it back into one of these equations, one of the original equations. Okay, so the original equation, x plus y equals negative 3. It's the first original one. X minus y equals 7. That's the second original. So we can substitute x equals 2 back into that. So wherever there's going to be an x, we can put the number 2. Okay. So first equation was x plus y equals negative 3. So sub in x equals 2. Oops. That means that. Oops, I forgot to write the rest of that out. It's 2 plus y equals 3. Okay, so all I've done is where it says x in that equation, I've put the number 2. Okay, so I've substituted, instead of that letter now, it's that number 2. That means y is equal to minus 3 minus 2. Y is equal to minus 5. Okay, so I want to isolate that y. I'll do that by moving that 2 across to the other side. Okay, it's positive on the left, so it becomes negative on the right. Okay, so we get y equals negative 5. Okay, now we can check that by substituting y equals negative 5 into one of the other equations. Okay, so if you substitute that into equation 2 is x minus y equals 7. Okay. Subbing in y equals negative 5. So we have x minus negative 5. Okay. Taking away a negative becomes a positive. X plus x equals 2. Okay, now that's only a check, so if I look back, what I'm getting here should equal the same as that. Okay, now that part I just did, that check, you don't need to do that in the exam. But if you've got time, it's just a nice step just to confirm your answer, just to show that you've not got any signs mixed up, okay? You've not done a negative, if you're not taking a number over to the other side in the wrong way. Okay, so it's a nice to have if you've got a spare couple of minutes at the end of the exam. Okay, it's not necessarily something you do as you just work through that question. Okay, but always have it in the back of the mind. You can do a wee check by substituting back in. Okay. Anyone still copying? All good. So just to go back over the parts, okay, the method for elimination. Make sure the letter terms are both on the left-hand side. Okay. Put them in the column, x's and the y's, equals the whole numbers. Okay. Make sure the number in front of the second term, the y terms, are going to be the same. Okay. Then we can add or subtract them vertically, eliminating one of those terms, and that allows us to solve for the unknown. Okay. Just going through another example. We've got sitting on the sofa. It sounds wonderful, but my God, it's uncomfortable when you're trying to do this. P minus 3q equals 3. It's a terrible equal sign. We've got P plus 3q equals 9. Okay. We've got all the letters on the left-hand side, tick. We've got the same number in front of the second term. Okay, so number 3. At that point, the sign doesn't matter, but the sign dictates what you do at this point. Okay, we're going to add vertically both these terms together. Okay, so we're going to take into account the p's, add them vertically, get 2p. Okay, negative 3q plus 3q means we can eliminate the q term. 3 plus 9 gives us 12. Okay, so that leaves us with 2p equals 12. That allows us to go p equals 12 over 2. P is equal to 6. Okay. Top equation I'm going to write is 1. Second equation I'm going to write is 2. Okay, so I'm going to substitute p equals 6 into one of those equations. Either one, it doesn't matter. Whatever one you think looks easier to do, it can go into either. So I'm going to put it into equation 2. Okay, so okay. So that'll be 6 plus 3q is equal to 9. Okay, so it's just gone in place where that letter P is. Okay, so remember, it doesn't always have to be X and Y. Okay, these letters are just unknown variables. Okay, X and Y is just what we're used to because that's what we use for graphs when we don't know anything else. Okay, 6 plus 3q equals 9. That gives us 3q equals 9 minus 6. 3q equals 3. That means q is equal to 1. Okay. We can double check that. by substituting q equals 1 into equation 1. Okay. Equation 1 was p minus 3q. Okay. Minus p minus 3. 3 times 1 equals 3. Okay. Just put that 1 in a bracket. That just means it's 3 times whatever's in that bracket. Okay, so it's no different to any other time we use brackets. Okay, so anything outside it, it's going to multiply. So that's p equals 3 times 1, which is 3. Okay. P equals 3 plus 3. P equals 6. Is that the same as what we got earlier? Yes. Okay, that should be the same as that up there. Okay, so that step, again, is just a double check. Okay, so that's just a double check. The example, we had an example, we started an example and we got to literally the last line of it before it cut out. So I won't go over it, but if you want to see it again, it's at the tail end of last week's lesson. Okay, so from an hour on of last week's video, we introduced simultaneous equations. And again, it just goes through those rules in a slightly more detailed manner. Okay, so it gives one example. So I won't go over that again. I'll go on to the next one. Okay, so what happens when the number in front of those terms isn't the same? Okay, how do we get around that? We do it by multiplying those equations. Okay, so if we've got two equations, that's a 5 equals minus 7. We've got 3x okay. We've got equation 1. We've got equation 2. Okay. Now we want to do the same process. So we want to have all the x's over each other, all the y's, and all the whole numbers, which we do. So the format of what we're looking at is correct. Okay. The second part is we want this number and this number to be the same. Okay. So currently they're not, so we need to do something to make them equal. Okay. What we need to do is effectively, I'll call it cross multiplication, but it's not really. Okay. We're going to multiply the top one by 2. This number here. Okay. That whole equation. Okay. That whole thing. I'm going to multiply that bottom one by 5. Okay. Again, that whole equation. So if we rewrite 1 and 2, okay, equation 1, multiply that whole thing by 2. So we're going to have 8x plus 10y equals negative 14. Okay, so every single part, I think I might cut out there. Every single part of that equation multiplied by the number 2. Okay, so 8x plus 10y equals negative 14. The one underneath it, we're going to multiply by 5. Okay, so I'm going to have 15x plus 10y equals negative 35. Okay. That okay to follow? Okay, so we're just taking the number in front of the second term and multiplying the other equation by it, if that makes sense. Okay, so we're just making those second terms equal. That means we can do the add or subtract, okay, to eliminate that. So to eliminate that, sorry, someone's just coming in. Just wait till the log on. Okay, To eliminate that second term, this time we're just going to subtract the bottom one. Okay, so we can add or subtract that bottom one to the top to eliminate that. Okay, so we're going to do 8x minus 15x this time, 10y minus 10y, and minus 14 minus 35. Okay, which becomes a plus. Okay, so draw a nice wee line. 8x minus 15x, going to give us minus 7x. Okay, 10y minus 10y is going to give us 0. Okay, so they eliminate each other. Okay, and then you've got minus 14 minus 35. So just be very, very careful. That symbol and that symbol. Okay, so that will give us the sum minus 14 minus 35. Okay, so just be very careful of that. So it's minus 14 plus 35. Okay. Minus 14 plus 35 is going to give us 21. Okay, so just tidying, writing that in a wee bit neater form. Minus 7x is equal to 21. That allows us to solve for x. Okay, so I just want to isolate x. 21 over minus 7. Okay. I'll just give some minus 3. Okay. I'm going to take that x equals minus 3. We're going to substitute in x equals minus 3 into equation, the original equations. Okay, so either 1 or 2, it doesn't matter. Okay, so equation 2 maybe looks easier. I'll do equation 1 just to keep it the same. Okay, but it can go in equation 2. Okay, so equation 1 is 4x. So 4, in fact, I'll just rewrite it. So we've got it 4x plus 5y equals minus 7. So into this position, I'm going to put this number. Okay, so it's going to be 4 minus 3 plus 5y equals minus 7. Okay, remember that bracket just means the 4 multiplies that. Okay, so 4 times negative 3 is negative 12 plus 5y. We want to isolate y, so we want to get rid of that negative 12 over to the other side. Flipping the side, flips the sign. Okay. Y is equal to 1. Okay. Okay, equation 2, 3x plus 2y. So this is just a check. Okay, so the question in the exam would finish there. Okay, this bit's just a check. So y equals 1 into equation 2. Okay, so 3x plus 2 times 1. Okay, so it should work out the same. In this case, it does. It's just a nice to have. Okay. Okay, I'll give you one more example, then I will allow you to work independently. Okay. So have a wee go yourself. Okay, so I'll do one more example, then we'll have a wee go ourselves, just to work through a couple of examples yourself. Okay. I'm doing 10 tonight, if we can get it to work, to get a wee breakout room. Okay, so those unfamiliar with breakout rooms, effectively it splits up the class. Okay, so there's 9 of you tonight, so I'll do 3 breakout rooms, so you work in threes. Okay, so effectively you can be in the breakout room and talk to each other. Okay, so I'll give you a couple, sorry if you can hear my dog in the background, once in the room. Okay, so I'll give you a couple of questions to work, and you can just work with the 3 of you, talk it through, try and work it out. Okay, help each other, and then we'll come back together and get the answers together. Okay, if that makes sense. So I intend doing that till in the last hour or so. Okay, see if it works. Okay, so last example, then I'll let you work individually. Okay, so we've got 2a plus b equals 10, 3a minus 4b equals 26. Okay.
Can I just ask a question? That's all right.
Yeah.
Does it matter what you times it by? So see, like the last one, if we times it by the middle number, can you do it for the first number? So see this one.
Yes.
Could you do like the first one times 3 and then the second one times 2 to get 6, obviously? So it doesn't have to be the middle one, then it can be the first one? Or does it need to be the middle numbers?
No, it can be the first one, and you can eliminate that. It's easier in regards to setup wise if we do the second one and just be consistent with that.
Yeah, that's fine.
I can't think of any reason why that would be the case, but no, you can. So you can eliminate either A or B in this case. Okay, it just seems to be the way that the second term usually works out easier to eliminate than the first term.
Okay, that's fine, thanks.
But we could give that a go in this one and just experiment with it. So I'll do the second term first, and then we can have a wee look and see if that method will work through it together.
It's all right.
No problem at all. That works. Okay, so looking at the second term, okay, want the B terms to be the same. So the B term on top is 1. Okay, so we want that to be 4. So we want to take that 4 up, multiply that 4. That just gets multiplied by 1. So it doesn't, nothing happens to that second term, the second equation. Okay. So just rewriting them out again, that would become AA plus 4B equals 40. That stays as 3A minus 4B equals 26. Okay. We want to eliminate that second term, so we're going to add them together, okay, because it's plus 4b minus 4b, so we need to add the terms together to eliminate it. Okay, add them vertically. We've got AA plus 3a, which is 11. Okay, that term and that term eliminates each other, and those terms, what was that? Okay, and A is equal to 66 over 11. A is equal, noisy house downstairs, isn't it? A is equal to 6. Okay. Substitute that into 1 or 2. Okay. Substitute that into equation 1. It just works a wee bit easier. Okay, you've got 2a plus b equals 10. Wherever there's an a, we'll substitute in the number 6 plus b. That would be 12. 2 times 6. Okay. Just be consistent. Sub that into 2. Okay, so that's the end of the question. Okay, I'll sub that into 2 to check. Okay. Sub b minus 2, b equals minus 2 into equation 2. So that's 3a minus 4b equals 26. 3a minus 4 minus 2 equals 26. Minus 4 times minus 2 is going to be plus 8. Is that the case? Yeah. Okay. So it's just a wee double check. Plus b. Okay, so question was asked, does it need to be the second term? The answer is no, it could be the first term. Okay, again, you just do the multiplication by whatever number's in front of that. So you just multiply it by 3, multiply it by 2. Okay, and you should be able to work through that and it would work through the same. Okay, but be consistent. So I'm not going to do it just for a consistency thing. I just want you to have in your mind, okay, that second term. Okay, and we'll just follow through and we'll just keep that practice the same. Okay, so I was going to work through that, but I don't want to cloud anything. Okay, I'm making. Okay, so talking for about 40 minutes, so good time to have a wee go yourselves. So as I said, we'll do sort of breakout rooms, sort of discussion ones later on. If we have a wee go. Some of these just ourselves right now. So just working from pack 2. And if you can open pack 2, I'll work from that later on as well when you're working as a sort of group. Okay, so I've got page 19. Okay, so page 18 sort of introduces you. This should be not too bad. Okay. Ignore the ones that say graphically, and we'll go over them later on as well. Okay. Okay, so ignore questions 1 to 4 right now. and 5 actually, because you need to draw that out. Algebraic. Right, let's have a wee look. So 19 y equals x, blah, blah, blah. Okay, I would say work from question 3. Have a wee go at question 3 yourselves and try and work it out. Okay, if you want to do some easier ones, question 2 is similar to the ones that I started with, the first 2 examples I gave this evening. Okay, the first example is essentially, okay, so if you want nice easy sort of entry into it, question 2, I think question 1 would just confuse you a wee bit, so just miss out question 1. Don't really like the way it's written. So question 2, question 3 is what we've just been working through. Question 4, question 5. So 3, 4, and 5, we should be able to have a good bash at. Okay. So that's what we've been working through, those examples. No problem. Okay. So have a wee go. So page 19, question 3, and then 4 and 5. Okay, have a wee go at them. Let's say take 20 minutes having a wee go at them and then a wee 10-minute break. So we'll come back together at 7:30. Okay, makes sense. Start that recording again. Okay, I said to you, don't look at the questions before that, okay, in regards to, they talk about graphical solutions, okay, so they talk about drawing out the straight lines, okay, and then finding the point of intersection, okay, so with simultaneous equations, we can use that, we can use the equations for 2 straight lines and then find the point of intersection. Okay, so there's nothing drawn out in this booklet, which I don't like. Okay, so there's no graphs drawn out. So let's have a wee look at what that would take the form of. Okay, so we're thinking about something like this. Okay, so you've got an XY graph. Okay, so that's something we're familiar with, that XY graph. Okay, and plotted on that, you'll get given 2 straight lines. Okay, and you'll get asked to find the point of intersection. Okay, so what they're wanting you to find out is where these 2 lines cross. Okay, so this point here. Okay, so that point in there, where those 2 lines cross. Okay, so do that by simultaneous equations. Okay, so we find the x and we find the y, and that's your coordinate of where that intersection is. Okay. So let's have a wee look at this. So you'll usually get given equations that on the face of it look quite tough. Okay, so it might have the x on one side, the y on the other, and the number sort of there as well. Okay, nothing too outrageous. Okay, but it might not be in the organized in the way that you would think. Okay, so it might throw you a wee bit. Don't be worried about that. Okay. All that straight line is in that format, y equals mx plus c, and they've just rearranged that a wee bit. Okay, so straight lines always follow y equals mx plus c. They just happen to have rearranged that. Okay, so you could rearrange that back into that format. Okay, so if they ask you what the gradient is, okay, you would have to organize it in that format, and then your gradient would be 5. Okay, the thing you would just have to watch out for would just be if it became a positive or a negative. Okay, and that's not even true. The gradient would be 5/4. But so equations of straight lines, they'll give you two. They'll ask you to work out the point of intersection. That point in there. Okay, and you'll do that by numbering these equations 1 and 2, and then working through that same process as we've been doing. Okay, so that equation 1 is given as 5x equals 4y plus 22. Okay, equation 2, they've given it 3x plus 5y equals -9. Okay, the first thing we want to do is tidy up that equation number 1 to bring all the letters over to the left-hand side. Okay, so that's the first step that we want to take. We want to take equation 1 and bring all the letters over to the left-hand side. Okay, so that would give you 5x minus 4y plus equals 22. Okay, that means that allows us to put equation 2. Okay, we don't need to change anything in equation 2. Okay, but now we've got the letters above each other. Okay, so we can work out columns. Now we've got something we're a wee bit more familiar with. Okay. We want to eliminate this second term. So we're going to multiply that top equation by 5. And that bottom one by 4. Okay. Working through every single part of that equation, multiplying that by 5, gives you 25x minus 20y equals 110. Okay. Bottom one would be 12x plus 20y equals 4 times -9 is -36. Okay, and now we've got a second term which we can do the elimination with. Okay, so that we added them up vertically. Okay, we get 37x. We would eliminate those two. Okay, and then we'd get 74. Okay, 37x equals 74. X equals 74 over 37. Okay, you'd be expected to do something like that without a calculator. Okay, so 74 divided by 37 is going to give you 2. Okay, so 2 37s go into that. Okay, you can remember you can break that up. So 37 times 2. Okay, so 30 times 2 and then 7 times 2 and add them together. It's probably the easiest way. Okay, so 30 times 2 would be 60. 7 times 2, 14. Add them together. Okay, so 37. 74 divided by 37 would be 2. Okay. That gives us our first unknown. So that means the x coordinate of that intersect, okay, of that point there, is going to be x equals 2. Okay, so that point there equal 2. Okay, now we need to find the y term. So we plug x equals 2 into either equation 1 or 2. Okay, again, doesn't matter. Okay, so into equation 1, And you can keep it in this form if you want. Okay, so that was originally the way they gave you it. Okay, x equals 2. Okay, so okay, substitute into 1. Just tidy that up a bit. Okay, 5 times 2 is 10, equals 4y plus 22. Okay, that would give you 10 minus 22, 4y. Okay, all I've done is just taking that 22 across. Okay, so that's minus 12 equals 4y. Okay, so minus. Okay, so just move that across. And that just gives us minus 3. Remember that equal sign just means left hand side equals the right hand side. Okay, so I can write that out like that, or y equals -3.
Yeah, I was just going to say that because see the set where you do 10 minus 22 equals 4y, I just switched it down to 4y equals 10 minus 22, which is y equals -12 over 4, which is y equals -3. So would that be right as well?
Yep, perfect.
Cool.
Okay, so you've just organized, so you've just taken it at this point and just moved them in a different order. So that's absolutely fine. Okay, so if you wanted to move y over here at this point and then bring 10 over, that works out perfectly. Okay, just be careful with that. Okay, but I've no problem with you doing that if you're comfortable with it. Okay. That and that is the same thing. Okay, it means the same thing in maths. Okay, so that equal sign allows us to do that. Just be careful, remember, just be careful if it's an inequality. If you're doing that and you want to write it the other way, just be careful what you're doing there. Okay, and we did an example of that. But absolutely fine, changing that earlier. Okay, so y equals -3. Okay, so if we go back up to that intersection, okay, you know that y equals -3. Okay, so that means that's -3 there. We can write that out in the coordinate form. Okay, so our xy coordinate. So if they ask for it in coordinate form, so what's the coordinate of intersection? Remember, we need to do that bracket. Okay, remember that bracket is just xy. Okay, so that would be the coordinate. Okay. Now, often the picture gives you the clue of where that's going to be. Okay, it doesn't give you the numbers, but it allows you to see, okay, x is going to be positive and y is going to be negative. Okay, so remember when the xy graph's there, that's going to be 0. That's your 0 point. So everything to the right hand side of that's going to be positive x. Everything to the left is going to be negative x. Likewise, below it, negative y. Above it, positive y. So you've already got a clue when you see that. Okay, x is going to be positive, y is going to be negative. Okay, wee bit of work to it, and that's why you usually get quite good marks for it. Okay. Anyone still copying that? Okay. Super. Oops. Okay, so this is a past paper question. Okay, so this is past paper. This is 2017. Okay. And paper 1, so it's non-calc. Okay, so this is in the non-calculator paper. Okay, so we've got 2 lines there, similar to what we had. We've got 2 equations. They've actually got it in the format that we'd want it. Okay, so they've got x, y, and then the number. Okay, so we don't need to rearrange these equations. We just need to be aware that we've got equation 1, we've got equation 2. Now, importantly, what you have is equation 1 and what you have is equation 2 doesn't matter. So I could switch them when we stack them on top of each other. Okay, the question will ask what the intersection is. So you're looking for this point here where those lines cross. Okay, you've already got a clue to what X is going to be positive and Y is going to be positive as well, because the position on that. Okay, so you've got 0 down there, positive Y, it's going to be a positive X. So it points you in the right direction. Obviously doesn't give you the answer. But okay, so let's just go through the process, write these out. 3x minus y equals 2x plus 3y equals 19. Okay. Equation 1, equation 2. Want to make that second term the same. So we're going to multiply the top one by 3. Okay. The bottom one, we don't need to do anything to. Okay. Just need to multiply it by 1. Okay. So multiplying that by 3 gives us 9x minus 3y equals 6. Going through the process for 2 give us that. Okay, now we can just add them together. Work through our process, 10x. That eliminates each other. And that's 25. Okay. That gives us x equals 25 over 10. And we can simplify that down into 5 over 2. Okay, now I'm going to keep it in fraction form because we've worked with fractions before. Okay, so we've worked with fractions and we should be able to deal with fractions when it comes to multiples and when it comes to addition and things like that. Okay, so I'm going to take x equals 5 over 2 and I'm going to substitute that into equation 2. Okay, because we don't need to do anything with x, so x will just be 5 over 2 plus the y equals 19. Okay, so I'm going to substitute that into 2. Okay, so 2 was x equals, 2 was x plus 3y equals 19. Substitute where the letter x is with that 5 over 2. Okay, it's not multiplied by anything, so that fraction just goes in. Plus 3y equals 19. Okay, and then it's just a case of rearranging and working out for 3y. Okay, so we're trying to isolate y. Okay, so 3y, move that 5 over 2 over. 19 minus 5 over 2. Okay, remember 19. Okay, any whole number can be written as a fraction. Okay, so we've got 2 fractions. We just go through our rules. Okay, our kiss, smile. So cross multiply and then multiply the 2 at the bottom. Okay, so any whole number can be written as number over 1. Okay, so we've got 3y equals 2 times 19 is 38. 1 times 5 is 5. Be careful what sign's in the middle there. 1 times 2 is 2. Okay, so we now have 3y equals 33 over 2. Okay, I'm going to keep that as is. That y is like that. Okay, bringing that 3 over. That becomes 2 multiplied by 3. Okay. So be comfortable with bringing a multiple over when you've got a fraction on the other side. Okay, so that multiple obviously becomes a divide, but if you've got a fraction over the other side, then that bottom, the denominator, just multiplies together. Okay. Simplify that down. Okay, so what can you do to both of those terms? Divide both of those terms by 3. Okay, and you've got 11 over 2. Okay, and that's as simple as that fraction can go. Okay, so you've got x equals 5 over 2 and y equals 11 over 2. Okay, so your coordinate, writing it out in coordinate format, we have 5 over 2, 11 over 2. Okay, so slightly trickier because they've thrown in that fraction. Okay, but not as hard as some fraction questions you can get. Okay, so it's just throwing that wee bit of extra layer in there, but it's nothing too difficult. Don't let that throw you. Okay, so the coordinate xy would be 5 over 2, 11 over 2. They're both positive. So you've got your diagram. Does that make sense? Yes. Okay. 11 over 2, that would be 5 over 2. Okay. Odd coordinates, but essentially that's what it is. Okay, so I would leave that in fraction form. Okay, it's non-calculator. That was a non-calculator paper in 2017, that question. Okay. It wasn't too bad. Any questions on that? Super. Okay. Guys, just before we start stories, I'm just going to give us another 5-minute break before we kick off, okay? It's been a wee bit. So take until 8 o'clock, guys, and then we'll get back on. Okay. We'll take until 8 o'clock. It's recorded. Okay, so the questions in the booklet are actually, they're more than enough extensive in here. So I'm just going to stick to some of these. I'll give one additional. Okay, but essentially from page, what's this? Page 21 onwards. Okay. So essentially, you're given a wee story. You need to pull out the data. You need to put it in the form of 2 equations, and then you need to solve for the unknowns. Okay, so before we get into the right juicy ones, okay, we'll do 1 and 2, just to have a wee look at it. Okay, just to start building up our understanding of it. Okay, so question 1 there, find 2 numbers whose sum is 56. Okay, so just take this one step at a time. This is the really important part of these questions. So find 2 numbers whose sum is 56. Okay, so the sum of 2 numbers is adding them together, and whose difference is 16. So the same 2 numbers add together to make 56, and you take away the second one from the first one to get 16. So creating 2 equations from that. Okay, so creating 2 equations from that. Okay, you've got 2 numbers. Okay, they're not giving you those numbers, so you just need to find 2 variables, so 2 letters. Okay, so we can just use X and Y, or we could use A and B, whatever you want to use. Okay, so they sum together to make 56. So A plus B, you add together and they make 56. Okay. And whose difference is 16. Okay, it's like a wee riddle. Okay, whose difference is 16. So A minus B equals 16. Now we've got two equations. It's a simple case of just working through that. Okay. So we don't need to change anything. We don't need to multiply by anything. The two numbers here, okay, in front of the second term are the same. Okay, so we can just add that first expression and the second expression, give ourselves 2a, cancel them out. 16 would be 72. Okay, just tidying that up a wee bit. A would terrible written A. Okay. Did everyone see from that question, so from that bit of information, from that one line, where I got those two equations from? Okay. Perfect. Okay, so we're getting an unknown as A is 36. So we can substitute that into, let's call that equation 1, equation 2. Okay, let's substitute that into 1. Okay, A plus B. Okay. 36 plus B equals 56. B equals 56 minus 36. Okay. There we've got our two unknowns. Remember, you could check that. You could substitute B into one of the equations. Just double check that as well. Okay, I'm not going to. Getting a wee bit short in time, but we'll move on. Okay. Question 2 is quite similar in that respect. Two numbers whose sum is 22. Okay, and then it just adds a wee bit of added complication to it. Okay, it's not very nice. 3 and 4 aren't particularly nice, okay, but it's just getting you into that idea of taking information from a bunch of lines. Okay. Why can't I roll down? What would be more likely to come up is something like this, something like question 5. Okay, something like question 5. Okay. You've got, I don't know why I've done question 6. Let's do question 6. Okay. You've got a bit of information there. So question 5, you've got 4 chocolate bars and 6 packets of crisps, together cost £3.40. Okay. Then you've got 10 chocolate bars and 3 packets of crisps, cost £4.90. Form simultaneous equations to solve them. Okay. So essentially, you're looking for the price of a packet of crisps and the price of a chocolate bar. So we want to assign a letter, a variable, so we can start putting this together. Okay, so I'm going to assign a letter to chocolate bar. Chocolate. And I'll just assign the letter C. Okay, what else did we have? Packets of crisps, which also starts with C. Okay, and crisps, just assign the letter D to it. Okay, just to simplify it so we don't need to write everything out. Okay, so if you see the letter C, we're talking about chocolate. If you see the letter D, we're talking about crisps. Okay, so come back into that question. So that first line, 4 chocolate bars and 6 packets of crisps together equal £3.40. Okay, so we've got 4 chocolate bars. We've got 6 packets of crisps, which we're calling D. And that equals £3.40. Okay. Second equation, 10 chocolate bars and 3 packets of crisps and that equals £4.90. Okay, so there's our two equations.
Sorry, they're still in the question sheet.
Good shout, my apologies. Okay, so there's our two equations. So 4 chocolate bars and 6 packets of crisps equals £3.40. Okay, and then 10 chocolate bars plus 3 packets of crisps equals £4.90. Okay, but now we're looking at that and we've got something that's quite familiar to us. Okay, we've got two equations. We want to work out what 1 packet of crisps is. So 1 letter C and then 1 letter D. Okay, so 1 of each. Okay, so we just work through that same process.
So you don't put the pound sign, you just change that to decimal.
Yeah, so you don't need to put the pound sign. Okay, so that's what we're working with. So you don't need to put the pound sign because you can, but it just makes it a wee bit messy. At the end, we'll reintroduce that pound sign. Okay. But for the equation purposes, the pound sign would just make it messy. Okay, we don't need it there to be able to sort that. Okay, so we've given the variable of the chocolate bar, the letter C, the crisps, the letter D. We've made 2 equations out of it. Now it's just a case of following that same process. Okay, so we want to make that and that the same number, so we can work through it. Okay, now we could multiply that by 3, multiply that by 6 to get the same. Okay, but we don't need to. We could just multiply that by 2. Okay, to bring that up, and that means both would be the same. Okay, so let's just do that. Multiply that by 2. Okay, which would give us no change to the top one. What would that be? £4.90 plus £4.90 is £9.80. Okay. Probably making this harder than it should be. Okay, and then we can just take that away. Okay. So we'd have minus 16C. Okay, 6's would eliminate themselves. Okay, we'd have £3.40. Where's my calculator? £3.40 minus £9.80. Okay, which would give us minus £6.40. So don't be worried at this point of the fact it's negative. Okay, the fact you've got negative on both sides means you're going to end up with a positive. Okay. Now, you can't get a negative price for a packet of crisps, so your final answer should be positive. Okay, but at this stage, don't be worried if you're carrying a negative. Okay, and C, moving that minus 16 across, minus £6. Okay, I'm going to use a calculator for this. £6.40 by 16. 40 pence. Okay, so 0.4 or 40 pence. Okay, so it'd be £0.4 or 40 pence. Okay, now we can take that 0.4 That's C equals 0.4. Substitute that back into equation 1 or 2. Okay, so equation 2, why not? Okay, so equation 2 is 10C plus 3D equals £4.90. C is 40 pence, so 10 times 0.4 plus 3D. Okay. 10 times 0.4 is just 4. Okay, so you can even do that. Plus 3D. We get 3D equals £4.90 minus 4. Okay. So should be able to do that. Should be comfortable enough with that. 0.9. Okay. Didn't lose anyone. Okay. So just substituting C into equation 2. Okay, you could have used equation 1, that's absolutely fine. Substituting that in, rearranging to isolate just D, and we've got D equals 30 pence. Okay, so chocolate bar equals 40 pence, crisps equals 30 pence. Okay. Did I lose anybody? Okay. Okay, so that's that question 5. Okay, question 6. It's very similar, so I'll just fly through it, and then I'll give you an opportunity to have a wee go as part of a 3. Okay, so we'll have 3 groups of 3. Okay, so I'll fly through question 6, just so we're working together. Okay, so very similar. Okay, just by different. Okay, so 4 sandwiches and 3 hot dogs. Okay, cost £7.50. 2 sandwiches and 4 hot dogs cost £6. Form simultaneous equations and solve them to find the cost of each. Okay, so 4 sandwiches, 3 hot dogs, 2 sandwiches, blah, blah, blah. So sandwich, give that just the letter S. Okay, hot dog, give that a letter H. Okay, as long as those letters aren't the same. Okay, so in the last question I didn't use C and C. Okay, because that was just being silly. Okay, so that's why I use C and D. So sandwich, letter S, hot dog, letter H. Makes sense. Okay. First part, 4 sandwiches and 3 hot dogs equals £7.50. 4 sandwiches, 4S, plus 3 hot dogs equals £7.50. 2 sandwiches and 4 hot dogs equals £6. 2 sandwiches and 6 hot dogs equal, no, that's completely wrong, wasn't it? 2 sandwiches and 4 equals 6. 2 sandwiches and 4 hot dogs equals £6. Okay, So there we've got two equations. And we can solve them simultaneously. So it's in the format we recognise. Looks like what we recognise, no problem at all. Really want me to do that. Okay, I'm going to stick to the second term. Okay, eliminating the first term might actually be easier, but we're just going to stick with the second term and go with it. Okay. Yeah, stick with the second term. Stay consistent. Multiply that by 4. Multiply that by 3. Okay, multiplying equation 1 by 4 give us 16s plus 12h. £7.50 times £7.50. Oh, sorry, £7.50 times 4. So that's 4, 7.5. So we've got 7.5 plus 7.5. Okay, that will give us 15. Okay, plus 7.5 is 22.5. Plus 7.5 would be 30. Okay, so if we know that double that's 15, double that again is going to be 30. Okay. Okay. Two s times 3, 6s, 4, 12h equals 18. Okay, this time I'm going to subtract them. Okay. Yeah. Subtract them, 10s. Eliminated. Oops. Oh. 30 minus 18 is 12. Okay. S equals 12 over 10. Okay, we should be able to do that without a calculator. That would give us 1.2. Okay. That would give us S equals 1.2. Okay, so if we were going to write that out fully, S would be £1.20. Okay. Okay, so I'm going to take that S equals 1.2, and I'm going to substitute that back into equation 2 again. Okay, it looks a wee bit easier. Okay, so equation 2 was 2s plus 4h equals 6. Okay. 2, 1.2. 2 times 1.2. Okay, it's going to be 2.4. Okay. 4h equals 6 minus 2.4. Okay, I'm going to keep it in decimal because we're talking about money. Okay, so just imagine £6 minus £2.40. Okay. £6 minus £2.40 would give us £3.60. Okay. £3.60 divided by 4. 990. Okay. So, don't know how you're familiar with dividing. If you need to look over it again, okay, you can do the sort of long division method. That works with decimals. Okay, so it doesn't go into 3, 3 moves across, it goes in 9 times. The decimal stays where it is. Okay, so if you're not, you should be able, you'd be expected to do that without a calculator or something like that without a calculator. Okay, getting to 0.9. Okay, setting a division up like that. Okay, could be quite useful to you. Okay, so have a wee look, probably national 4 type stuff. Okay, so H equals 0.9. So H is the hot dog. 0.9 is 90 pence. Okay, so 0.9 of a pound is 90 pence. Okay, so we've got hot dog. And we've got, what was the other sandwich? Okay. Any questions on that? Nada. Super. Okay. Right. Has anyone not got the use of a microphone? Stick a wee notice in the chat if you don't have the use of a microphone. Okay, perfect. I'll get someone dropped out there. They dropped out. We'll chase them down. Okay, so my plan was to put you in 3s, but someone just disappeared. Okay, so I don't want to leave someone as a 2, so I'll put you in a 4 and a 5. Okay, so all I'm looking for you to do is just introduce each other, say hi, okay, and then have a wee go at question, well, as far as you can really, 8, 9, 10, okay, and then talk it through with each other. So miss out question 7. I just don't like question 7. So miss out question 7, okay, 8, 9, and 10 should be very similar to what we've just done, okay. I don't want to put someone in a group of 2, so I'm just going to do two rooms, okay. Shouldn't maybe take 5 minutes each, 5, 15. Come back together at 1:45. Okay, that'll give you 20 minutes to introduce each other, then work through. Even if you just get 1 or 2 of them done, that's fine. Try 8, 9, and 10, and then we'll come back together at 1:45. Okay, I'll set that up.